All right. Hello, everyone. I'm Bernd, and today is day 20 of Advent of Code. Today's puzzle was a bit easier, in my opinion, than yesterday, so let's check it out. Our input today will be a long list of numbers, and what we want to do today is reorder that list. So if we look at the list, then we first look at the first element, and then we move it according to its value. In this case, 1 means we move it once to the right, and then we update the list. And then we look at the element that was originally in second position, and we again move it according to its number. So it's 2, so it means move it 2 to the right. So you're going to move it here, and then it will turn up between -3 and 3. And then we look at the third element in the original list, and again we move it, and -1 means to the left. And if we go past the beginning or past the end, it will just turn up at the other end. So we move this 3 -3 would move 1 step, 2 steps, 3 steps, and it would end up between -2 and 0. Okay, in order to solve this problem, we note that by moving elements around, if you move them a lot of steps, then the index of a lot of elements might change. So it's a lot of changing values in our code if we save each index of each element. But we can note that the order for a lot of elements, the order does not change. So for this whole subsequence, it stays exactly the same between the first two moves, for example. So if we for each element save the next element, then we rarely have to change anything because only a few of those next elements will change at each time step. So let's have a look at the solution. So of course we need to read the file and split it into lines, and then we define a function move elements. So we want the element of index I. We need the numbers. We have a dictionary of next element and a dictionary of previous elements that we will update. Then we need to move the elements for a certain number of steps. So principally this is the number at the corresponding index. However, if we move this element, if we have like 6 elements and we move the 6 other elements, and we move the element 6, we're supposed to move the 6 element 6 times, then we'll just end up at the same position because it will roll around. So there's no point in moving it more than the number of other elements. So we can take this value and take it modulo the number of other elements, which will be given by this. And then, conveniently, this also will get rid of negative numbers and make them positive, but while corresponding to the same movement or the same new position. Then, if you're supposed to move for 0 steps, we can just return. There's nothing to update. And then we'll save the old previous and the old next element of I. And then we want to find the new next and the new previous. So we start with the new next being equal to the old next. And then just for each move, we update the new next to be the next element of what it was previously. And then the new previous will be just the element before the new next. Okay, and then having this, we know the old previous and the old next and the new previous and the new next. So we can update all of those things or the corresponding dictionary entries. So the next element of the old previous was the element I, but now it's the old next because we remove it from this position. Similarly, the previous element from the old next was I, and now it's the old previous because we remove I from this position. And then we need to add I to the new position. For that, the next element of the new previous will no longer be the new next, but now will be I. And the previous element of I will be the new previous. And the next element of I will be the new next. And the previous element of the new next will be I. That's already the main part of the code. So we don't want to just move one element, but we want to move all of them. So luckily the elements are moved based on original index, or so we can just go have the element index in 0 to length of numbers -1 and move the element of the corresponding index. Okay, with this we can solve the problem. So we'll parse the numbers, which will just be given in the file. And then the next element starts with the dictionary where each element I just maps to index I plus 1. But from the last one, so if I is equal to length of numbers -1, then the last element will map have 0 as its next element. So we have this modulo length of numbers, and the previous element will be exactly the other way around. Then we are told to move all the elements, so that's what we do. And for a solution, we consider first an element with the element with number 0, and then based on from that element, we wanna get the element at index 1000, 2000, and 3000. So first we need to find the element with number 0. So we start with the element with index 0, and then we just update the current element to be the next one of itself. And we do that while the number is not equal to 0. And then eventually it hopefully will be 0 and we'll get out of the while loop. And then from this element, we're gonna now want to go 1000 steps forward, 2000 steps forward, and 3000 steps forward, and look at the corresponding elements in our linked list. So yeah, we just do this by updating the current element 1000 times, and then whenever the I is equal to in one of those indices, we add this to the solution and print it out. Okay, can have a little test, and that looks good. Amazing. So let's go on to part 2. The difference for part 2 is that we have a description key, and then we're supposed to multiply each element by this description key to get the actual numbers and to get how much we're supposed to move each element. And also we want to move all the elements 10 times, but each time based on their original indices. So that makes it pretty nice. So we just reuse the stuff from part 1. This time we move all elements 10 times. And because we have this modulo in the previous part, this like multiplying these numbers by a large number does not matter much. And yeah, then for the we also do the same part as before to find the solution. Again, let's do a little test. And that looks good as well. And if you run it on a proper input, it also gives us the right solution. Okay, that was it for day 20. Hope you enjoyed today's puzzle, and see you around.